it is also potential that the release could have not only resulted in concussive explosion, but it may have been a rapid chemical reaction that would have resulted in, I'll say, plastic material flying everywhere. Hello, and welcome to today's episode of the Exposure Scientist podcast. Today is May 26, 2026, and I have had a number of requests from a number of different media organizations to have discussions on the accident or chemical release or potential chemical release for the methylmerthacrylate material that is in Orange County, California, near Los Angeles. And I want to give some information and some context to provide some clarifying information, so we don't have to repeat it. It may be a good source, or at least a good starter to understand what we look at as far as exposure science, what we're looking at as far as the constituent that we're worried about, getting a little into the chemistry, but more so, what's the ultimate concern here? And some discussion on some information I've seen out there in the news with some discussions that may not be exactly correct, but we'll get into that. So I'm going to read from this to you. This is a proclamation of a state of emergency from the state of California. It talks about on May 21st, 2026, a chemical storage tank containing approximately 5 to 7,000 gallons of methylmerthacrylate began emitting, they say, toxic fumes at a facility near the city of Garden Grove within Orange County. So this tank is used as, I guess, in the manufacture of something at this type of facility where it's stored on site in certain storage conditions. Now, one of the problems that I understand here, again, I don't know all the details, and details are a little bit sketchy. Again, the information is coming out as bits and pieces of it, and it's hard to, kind of figure out what's going on. What the idea that I'm gathering from at least the emergency proclamation and the little bits and pieces of information that I've seen is that this material is they identified it as methyl merthacrylate. This material is used as is combined ultimately to make, I'll say, hard plastics or plastics type materials to use for other processes. So we can look at methyl merthacrylate almost as an intermediate in the manufacturing of certain end products. What this means is that in order for it to remain stable is maybe not the best word to use, but at least viable for use, is that that it has to be stored and it has to be stored in a proper way. Now, as I get it, looking at they identify this as a monomer, which ends up ultimately as a polymer from the manufacturing process, and that process has to be done again under controlled conditions. Part of the problem here, or at least what was identified as, and runaway is not the right, I don't think, appropriate terminology, but there's at least a discussion of the reaction getting away from the facility that it is intended to be stored at. So ultimately, looking at the reaction, is looking at ultimately, and let's take a step back. Methyl methacrylate starts out as methacrylic acid. MAA is the abbreviation. So from methacrylic acid to methyl methacrylate, there's a process to make that. And then from methyl methacrylate, it goes under polymerization to polymethyl methacrylate. So there's lots of chemistry involved here. The chemistry is the important part because to aid in reducing the reaction of this material to form, I'll say, a hardened plastic substance. Because right now, this is kind of a liquid substance. It's sitting there as liquid. They have stabilizers in these materials. Generally, and not going too deep into chemistry, there are reactions that can occur within the material itself. And there are stabilizers that kind of scavenge what we call free radicals. They scavenge onto these materials so to make sure that the reaction does not proceed in an unplanned condition. Now, I don't know exactly what happened here. I think that it's still going to be pieced together as far as any investigate it further in the future. But I think it's important to understand that somehow this material started to polymerize. Don't know why, don't know if it was temperature or whatever. Now, I don't know much about the facility. I don't know really anything other than the name, which I'm not going to state here. It's in the release of the from the Proclamation of State of Emergency. You can go read it there. But they indicated that the temperature of the material as it sat, there's a temperature a thermometer on the tank, and it says that the thermometer only goes up to 100 degrees Fahrenheit. The temperature inside that they guesstimated was probably higher than that. Now, reactions as they go on, temperatures rise, and one thing that's important here is that the reaction uh, that undergoes here for methylmerthacrylate is what we call exothermic. It creates heat. That heat kind of feeds itself to create the process more and more. The reaction, that's why they call it kind of a quote unquote runaway reaction. It feeds itself the heat necessary to proceed down the reaction way. What they have attempted to do, and it sounds like they've been fairly successful at it, was cooling the tank down. I looked up the weather, if I can find it. The weather in Garden Grove, let's just say for today, the high looks like it's a high of 75, 78. They've been spraying water on it to uh, try to slow the reaction, to cool the reaction. At one point, I read something that they try to insert a thermometer into one of the valves on the tank. It sounded like the valve had already had some polymerization that had gone on. So I think a hardened plastic material had already crusted up the valve, so they could not get into the tank. So right now, this started, I think, started on the 21st. So the 21st was last Thursday. I'm getting the idea that they think that a lot of the tank now is probably hardened material where the reaction did not get too far ahead of itself. What I think the ultimate concern was that the tank was going to have an uncontrolled reaction and explode. I'm not sure that they were concerned. Again, I don't know. Again, details are hard to piece together with all the news information and public the public information officers release and everything. But it sounded like they were worried more so about the concussive force of an explosion from a reaction that was occurring at a fast rate that was in an uncontrolled condition. Those reactions, I mean, you've seen those big reactions. You know, when you think of explosive force, there's plenty of instances where combustible dust has occurred, where pesticide manufacturing facilities have resulted in uncontrolled releases of concussive forces, and there's a shock wave that goes along with it. That my guess is their primary concern here. They evacuated, I think, they said 50,000 residents from the area. So my guess is that is the primary concern. The exposure to the material was probably secondary, but again, I don't know. I think that they should probably go hand in hand. Now, we're going to cover some information about methyl methacrylate. A lot of you are probably familiar with it. Some of you may not be. But again, I think the big concern here was ensuring that the reaction, I'll say, was controlled. And I think the temperatures probably helped them out. Again, I said the high today is like 78. Tomorrow it's 68. Thursday it's 68. It's probably within the safe margin, at least externally, used in combination with the water to cool the material enough where it just kind of polymerized within the tank itself, and there's little to no risk. I say little to no risk. The risk of an explosive release is probably reduced. So, secondary to that is, I'll say, generally the concern of the methacrylate itself. And we'll cover I'll say some of the misconceptions, or at least some of the information that I've seen out there. So, methyl methacrylate. Probably a lot of you are familiar with methyl methacrylate, or you've heard the term methacrylate before. Um, I remember actually in grad school, a colleague doing a study on methacrylate. So it was more so ethyl methacrylate. I can't remember if methyl was included or not. So if you think about it, and you've probably somewhat smelled. If you look at acrylics that are in nail salons, a lot of the smell that goes on are methacrylates. Now, the majority of those should be ethyl methacrylates. And that's what my friend did a study on in grad school was what are nail salon tech exposures to these methacrylates. And it's an interesting, I'll say, concept. When they look at acrylic nails, they have to be made of something, a plastic type material. And I think it's important to contextualize, what exposures are. So I'll give you a little context. This is from FDA. It talks about nail care products. Try saying that 3 times fast. Um, it talks about in the 70s, 1970s, as we date ourselves here, FDA started receiving a number of complaints of injuries associated with the use of these artificial nails or acrylics. And they identified methylmerthacrylate, the monomer, as the cause of it, to causing fingernail damage and deformity and contact dermatitis. And um, they said anything in the 70s, pretty much it was like, if anything contains 100% methyl methacrylate, um, as far as combination of these nail products, we're not going to allow it. Interestingly, and including on the FDA's website, you can go look at this. They say no regulation specifically prohibits the use of methyl methacrylate monomers in cosmetic products. However, they said that um, they remove products containing 100% methyl methacrylate monomer through court proceedings, resulting in preliminary injunction against one place and seizures against others, volunteer recalls and stuff. So there's nothing that says you can't use it, but if you do, or 100%, but FDA is going to come after you. So they said, well, the safer route is the ethyl methacrylates. Now, it's not uncommon for some of the methyl methacrylate to occur as impurities in the products themselves based on the methyl acrylic acid. And that is interesting because, again, it's not 100%. There's always probably going to be some small amount. I'll just say the majority of it goes to ethyl methacrylate. There may be a small amount that's methyl methacrylate in there. But again, it's not 100%. So there is some, I'll say, safe use. It's not a, I want to say it's not a big deal, but when you think about methacrylates, you've probably heard that before. You probably smelled that nail salon smell before. And I think it's important for that information to say, okay, well, now I understand at least generally what methacrylates are, where they may have, where they could have been found. So this is something that I'll bring up. There are no, obviously, there are OSHA standards for methyl methacrylate. Those are occupational standards. Um, Again, those are not community standards. And I think that's important to understand that when you think of an OSHA permissible exposure limit, that is not something that says that from a community exposure that it has to be under. I'm going to quickly look up what that level is just to give you some context here. So for methyl methacrylate, the OSHA permissible exposure limit, the PEL, is a time weighted average 100 parts per million. NIOSH has the same recommended exposure level, REL, of 100 parts per million. And it's a good amount over it. Time weighted average over an 8 hour for OSHA over an 8 hour workday over a 40-hour work week. Now, I'm not sure how many people are familiar with these. They a lot of people are. Some of them are not. There are things that are called acute exposure guideline levels (AEGLs) that are put out by EPA. There is in what they identify as an interim acute exposure guideline level (AEGL) for methyl methacrylate. I'm not sure if anyone or how many people are aware of that, but you can easily go search up AEGLs and they're on the website. And just to give you some context, based on what their background information is, methyl methacrylate has an acrid, fruity odor, and its odor threshold is 0.049 ppm. Um, but realistically, for recognition, it says 0.34 ppm. So under 1 ppm, you can detect this fruity, sweet odor, which is probably a lot of people in the community around there were probably already smelling this, especially if there was a blow off valve. I don't know again if there was a blow off valve here or not, or if they were more concerned. And we'll get into that a little bit here. But understanding here, there are AEGLs and they're set up. They have AEGL1, AEGL2, and AEGL3. Those are called non AEGL1 is non disabling, 2 is disabling, and 3 is identified as lethal. So there are, and if you're not familiar with AEGLs, they're ranging from 10 minutes, 30 minutes to 1 hour, 4 hour, and 8 hours worth of exposure. And those are established, and people use those as community guides. I think it's okay to view those as data points in those community guidelines of what people may be exposed to or what you could potentially be exposed to over in an acute exposure scenario. And acute and chronic is, most people are aware, but I'll explain it to those who may be looking for news stories on this. Acute is short term, chronic is long term. You think days for acute and years for chronic. So when you talk about, for it goes back to toxicology. The dose makes the poison. The more of the material you are, the hazardous it can be, which means the less time you can be exposed to it. So, for example, the AEGL, the lethal dose, it says a 10-minute exposure is 720 parts per million, and the 8 hour AEGL3 is 180 parts per million, as opposed to the non-disabling amount of 17 parts per million ppm for 10 minutes. So it's important to understand that when these scenarios typically go on, if people, I'll say this very, we'll say tongue in cheek almost or gently, if people know what they're doing, they will set up monitoring stations for these. They will say, okay, well, we understand this is methylmerthacrylate. We're going to go out and do some sampling, some ambient sampling to see if any of this material has breached anywhere. We'll see if the material um, has expanded beyond, I'll say, the confines of the facility, beyond the fence line, essentially. And some of that is good information. Some people, a lot, if people know what they're doing, they will be able to deploy those monitoring activities and test for it, sample for it, and send in samples and everything else to identify if any of the methyl methacrylate has been released and what the concentrations were to understand risk. I don't know if that was done here. I hope it was. I don't know exactly the information. A lot of the information, as I said, is bits and pieces, and it's hard to get some context on what's going on. And I will. I had some news stories up here, and I always like to look at the news stories. They're always illustrative. And I talked about here one of the one of the bits and pieces I saw was, and again, I don't think this fits into the definition, but again, I talked about the explosive concussive force. Actually, the story may have been updated. There was a concern that this material was going to be identified as a blevy. For those that are not familiar with it, a blevy is a boiling liquid expanding vapor explosion. From what this is not I'll say a liquid that has a low internal temperature that's going to create conditions, again, not that I'm aware of, that's going to result in a blevy scenario. It may be more so the exothermic rapid reaction that causes an explosion. From what I recall from blevies and looking up on other websites, NFPA, um, that I don't know if that qualifies for blevy, but understanding that, I think the primary concern here was the explosive, I'll say, concussive force um, associated with it. Could the methyl methacrylate spread everywhere from that explosion? Potentially. Um, it is also potential that the release could have not only resulted in concussive explosion, but it may have been a rapid chemical reaction that would have resulted in, I'll say, plastic material flying everywhere. So, they talked about, again, I'm looking at these news stories. It's highly volatile, highly toxic, highly flammable. Um, you know, uh, I don't, I don't disagree that it's highly, that it there's vapor pressures associated with it, and there is some toxicity information. Um, Again, based on at least what I'm seeing, and again, I'm happy if you have any additional information, but it looks that there's a more so of a concern from the explosive concussive force. I think getting the accurate information when these kind of things is going on is hard. You know, what's important is, there's lots of things here um, that people should be aware of, and you should have this. Um, there are um, there are laws out there that says you kind of have a kind of right to know what's going on, or it's almost like the Community Right to Know Act. Um, that and helps firefighters understand what you have on site to let them know um, what you have on site, um, and that enables people. I couldn't remember the acronym. It's EPRA, Emergency Planning and Community Right to Know Act, 1986. My brain could not remember that. Chemical reporting, emergency preparedness, public awareness. You know, it's important for manufacturers to work with their local firefighters or emergency responders to say, okay, these are the materials that we have on site. These are, this is what you may need to be here for. How can we help you in preparation for any emergencies that may happen? Let's think of all the potential contingencies. Let's work together to figure out how we can do this. That may be why they said, okay, let's get, in these kind of scenarios, they may have been quickly prepared to get water on it right away. That's the important thing to understand is a lot of times communities are aware, and especially communities in California are acutely aware of what needs to go on to prepare for these kind of scenarios. So, you know, and it's almost like community right to know. You need to know what's in your community. That information should have certain that transparency for public health and safety, and you should have access to that information. And again, that information probably aided in getting this addressed quickly because they knew what was in there. They knew how to treat it. Um, as far as the response to ensure that things were monitored, or to if something did happen, let's say hypothetically something did happen, there was a release. Did we have appropriate monitoring equipment out there? Do we have appropriate, I'll say, crews or consultants that were on standby that could say, okay, let's deploy this stuff in the communities. So God forbid there was something that happened. You know, do we have data to say, even though something did happen, the releases concentrations are low? Um, that is important to know if that's in place. Not only is there a community right to know and be prepared to address the emergency, but also be prepared from the exposure science standpoint of let's ensure that we can quantify the exposure and not have to try to work backwards. Let's have actual on the ground data instead of hypothetical model data. And that's always hard, but is possible. So hopefully I gave you a little context or a little more information. Again, the stuff that's coming out is, their public information officers are out there giving information, but on the ground, what's being reported, what's being released, or what's being theorized in other stories is hard to put together because there's bits and pieces of stuff everywhere. I always see this and it's always difficult. So hopefully, this gave you a little context on what was occurring during this emergency. Again, from what I understand, it looks like this scenario has, I'll say, gotten to a point where they're no longer concerned with an explosion here. Now it's just let's contain it so, there aren't any potential releases. But what are we going to do? What are we going to learn from this? Are we going to have equipment just because something shouldn't go over 100 degrees? Is that where you stop thermometers from working? Do we have to say no? Let's prepare this, and just in case that something does happen beyond what we can understand, beyond just the basics of what needs to be done. So hopefully this gave you some context. If you have any information, I'd be welcome to hear it. I think the listeners would too. Please reach out. I'd love to share your information with the listeners. If you have any questions, please feel free to reach out. I'm happy to help you how I can. I hope you enjoyed today's episode of the Exposure Scientist podcast. I hope you learned something, and I hope to see you in the next one soon. Thank you. The views expressed in this podcast may not be those of the host or management. This podcast is for informational purposes only and should not be considered health advice. It is recommended that you consult an exposure scientist to discuss the particulars of your exposure scenario. Exposure science covers a broad subject area, including toxicology, industrial hygiene, and risk assessment. From occupational, community, or environmental exposure, exposure scientists apply scientific methodologies to understand exposure risks and apply controls when necessary. We at Exposure Assessment Consulting have this expertise. Please reach out to us at info@exposureconsulting.com for a free 15-minute consultation to discuss the specifics of your exposure scenario.